Welcome to our first video on the lathe, where we're going to deal with the left side of the lathe and identify all the parts, and also going to review some safety. So let's take a look. Safety review from before. We've talked about all these issues, but every time we introduce a new machine, we're going to mention these again, because this is the most important thing in Engineering 153, and that is being safe. We're going to talk about where the main power switch is, how to turn it on, where the control panel is, the headstock, the gearbox, and the DRO. And this is just one small part, although a very important part, of the lathe. Let's begin with our safety review. Hey, welcome everybody. Today we're over at the Applied Technology Center, where you'll be taking your shop class for Engineering 153. I'm here, John Waddick, with Don Howard again, and we're going to just review the safety again. As you see, I'm got my safety glasses on because my glasses aren't of safety quality. When you come over here, you have to make sure that you have your safety glasses. Don, some of the things we've talked about clothing before still apply. Notice that Don and I both have short sleeves on. We don't have any dangling jewelry. No hoodies, nothing from your neck. This is going to be a fast spinning machine over here that could easily catch and pull you into the machine. What about other, oh, Don, what's this? Oh, yeah.
Earbuds. These are also earbuds. These are considered long and dangly and could be a dangerous instrument to have on your body. A lot of you guys like to listen to music and iPods and things like that. You have this hanging around. It's just one more thing that can get caught up into the spindle, into the lathes, into the feed screws of these machines, or around one of these handles that are moving. So I highly recommend that you keep these things away.
Okay. Well, there's another thing there too, Don. Not only could it catch in there, but you're also diminishing your ability to hear what's going on.
That is correct.
Okay, so nothing dangling, no necklaces, no long hoop earrings, hair once again pulled back or put into a bun or under a hat. And Don, as we've always talked, one of the things the student should always know where something is, and that's the emergency stop. So before we do anything else with this, where is the emergency stop?
Typically, you will look for a large or red dialed type of button. It may be encapsulated around a yellow, so that way you can easily identify it. On this particular machine, the E-stop is right here on the control front of your machine. All right, and it's just a matter of depressing it, and it shuts the power off to the machine.
Okay, so Jason, why don't you get just a close-up where that is on that machine? And that's the E-stop. So always know where your E-stop, or emergency stop is what it stands for. Know where that is before you get started. Let's review what Don has just discussed with the safety. First of all, safety glasses need to be worn at all times in the shop. Number two, you should be wearing short sleeves. If by chance you come with long sleeves, you're going to need to roll them up above the elbow. You want to have no jewelry, no necklaces, rings, dangly earrings. No earbuds or headphones. You need to be able to hear what's going on. Not only that, the earbuds or any wires connected to you or your devices can get caught up into the machine and pull you in. Same thing with your hair. It needs to be tied back if it's of any significant length. And you need to know where your emergency stop is before you operate any machine. Mentioned in the previous slide was that you should always know where your E-stop is on a machine. And here you can see in this slide the arrow is indicating where that's located on the lathe. It's in the front of the machine, and it has that red button. If you see a close-up of it, you see it's a red button. Once you depress that, the machine will not operate. No power will flow to it. To disengage the emergency stop once things are safe and you've determined that it's safe to operate again, you can turn that in the direction of the arrow. and then your controls will begin to work again. All right, Jason, let's move around and we're going to do some part identification. All right, first thing, we're on the back side of the machine here, Don. Where is the main power button and how do you activate it?
As you can see, here is your main power box, and right here is your main power switch. All you have to do is rotate this, and now you can see lights energized. You may hear a beeping sound that's telling you that your digital readout, or better known as your DRO, has been activated. So your main power to the machine is right here. So if you ever walk up, you don't have power, check here. And you can also read it. It'll say on, off, or 0 or 1.
All right. So it's just turning it about 90 degrees, Don? All right. Okay. All right, let's move on to the front of the machine. Now, Jason, you may want to... This is the headstock, is it not, Don?
This area of the machine is considered the headstock, yes.
Okay. We couldn't hear Don, but he did say yes to that. So Don, let's go over some of the things, like first of all, the control panel. Can you tell us what's on the control panel and what we need to know?
As soon as we energize the machine, we can come around to the front side of this machine, and we can see that we have a coolant switches, we have a low indicator light, we have a high-low speed switch, and we have a high indicator light. All right, and this is basically your control panel. You have a 2-speed motor in your machine, so you can pick either high range or low range, and this indicator light is not indicating, thank you, but when you're in low range, it's equal to Roman numeral 1, and I'll explain later why, and Roman numeral 2 would be your high range, and you can see the indicator lights turn on. All right. So
let's review what we have so far on the left side of the lathe. The main power switch, you see the red button there. There's an arrow coming in case you can't find it, but that would be turned to the on or 1 position to start it and to the 0 or off position to take the power off. Coming around to the front of the lathe, at the very top left, Don mentioned that there was the control panel, which has 2 parts to it, or actually 2 controls, coolant on-off. In Engineering 153, you're not going to be using any coolant, so that should always be off. The other one that you will be using will be the speed range, and that has a low or high. Now, the chart that you're going to have to use on this machine doesn't say low or high. It says Roman numeral 1 or 2. So 1 is low, 2 is high. And although you can't see it on this photograph, the Roman numerals 1 and 2 appear on the top surface of the control panel.
on the front of your headstock, this is the whole thing. The headstock encapsulates your spindle and your speeds, your spindle speeds, and it also has a lever that will help you engage your spindle with your feed rate. All right, and these and it also has your feed reverse. We'll start out top. This is your feed reverse handle. It'll actually change the direction of your feeds from forward to reverse.
Okay, let's hold it right there. So feed is when your tool is coming in or going away.
Correct.
Okay.
All right. And the next two levers that are going to be important are these two levers, which represent your spindle speeds. How do I find out what spindle speeds I need? We would look over here on the chart. All right. I have letters A through B, C, and C.
Okay, let's stop. So we've just talked about the control panel, which has the coolant, which I don't believe you're going to use in Engineering 153. Are we?
You will.
So we don't have to worry about that. And then it has the high-low indicator speed range, which we'll talk about more in a little bit. All right, Don, moving down to the middle unit here, could you just tell us what are those knobs?
Yes, this middle section is still on your headstock, and it helps you control the spindle speed, all right, as well as engage your feed rate and a directional of your feed rate. All right, the first two levers you're going to be concerned of for spindle speed selection is going to be letters A through B, C, and 1 through 3. All right, and you can see on this chart over in the upper left-hand side that you can see you have a column with the letters and you have a row with the numbers, and you'll select the designated letters and numbers on your levers. All right, you have Roman numeral 1 and Roman numeral 2 with an icon above it that represents a motor, and that has to go back to your high and low speed spindle selection up on your control panel.
So just to kind of, if I understand this correctly, Don, to get the proper speed, I need to do the speed range, Roman numeral 1 or 2, and then the ABC, is it?
Yep.
And the 1, 2, 3.
1, 2, 3.
So the combination of all that will bring us to what's on the chart.
Yes, whatever desired spindle speed you would like. Yep.
All right, Don, so I see these two, but there's two more knobs there. What are those?
All right. This one here gets the ratio between your spindle speed and your feed rate set up. So that way, when we set up your gearbox, it knows that if I'm turning 5 thousandths per rev, that means how far will the tool advance in one revolution of the spindle. All right. So this lever here, D through G, will help set up that feed rate.
Okay. So right now we have two speeds we've been talking about. A spindle speed, which is how fast the material is going to spin,
Correct.
And that's with these two, and on the speed range. And then the other part we're talking about is how fast the tooling is going to move into the part.
Correct.
And that's where this D through G is used.
Correct.
Okay, so I have one more button. What's that?
All right, this lever selects your feed direction. All right, as you can see by the two icons on the left and right side, you can see that you have arrows pointing. So if I've selected this, the carriage is going to move this way. In other words, your tool will move towards the spindle. All right, if I chose this one, the tool will move away from the spindle. So you can actually choose what direction your feed is going to go, or which direction your tool is going to travel. All right.
All right, very good. So we kind of got the idea there.
Let's review the headstock and the knobs for setting the proper speed of the spindle. So the headstock was below the control panel. It's in the middle. And the first thing on the top left is the spindle speed chart. So with the combinations of the knobs A, B, C, and the 1, 2, 3, and then also the Roman numeral 1 and 2, that you can set your speed to various things. Okay. The D, E, F, G lever is for the feed rate. That's the motion of the tool. And we're going to get into that a little bit more when we get down into the gearbox. So that has to do with the feed, what's known as the feed rate. The top right lever is the feed direction lever, and right now when it's pulled to the right, that means the tool is going to move from right to left, or toward the left. All right. Now these bottom two levers, the A, B, C, and 1, 2, 3, they correspond to the spindle speed chart. The other thing that you don't see here for the spindle speed chart are the Roman numerals 1 and 2, and those are found on the control panel up above. So that right there is the headstock. Two of the levers have to do with feed rate, two of the levers have to do with spindle speed, and the chart shown here is the spindle speed chart.
Now there's another control unit down here with even more levers. I'm getting confused, Don, so hopefully you can help me out here.
All right. Just below the headstock you have your gearbox, and in the gearbox you can see we have a number of different charts here that you may have to get involved with. For our engineering students, you're going to stay mainly focused on here, and this is your feed per revolution charts. You can see by the icons on the right hand side, you have one with an arrow pointing towards the spindle, all right, going towards the left. That's a feed rate designation for your longitudinal feed. In other words, my tool is moving from tailstock to headstock. All right, you pick any one of these numbers, you look it up on the chart, it tells you what lever has to be set where so you can get a longitudinal feed. The other one is the chart that you'll be concerned with is your cross feed. All right, and you can see that with the arrow in the tool bit.
All right, so this feed rate thing, Don, first of all, we go back up to this center console. You have to choose a letter there. And then there's 1, 2, 3, and then 4. We need to have those all concerned too?
Yes, you do. And when you look at this chart, you'll see that you have an area here. You see this lever here. This lever means I need levers set up in M. All right. Then I have a row across here. We have the D, E, F, and G. Now we go back up and we can look at here. So if I wanted to do 5 thousandths per revolution, which is 0.005, I'll use that for an example. The closest one we have is 0.0051, which is ME, and we slide across here to 6. All right? So we have to get all the levers set up properly. We look up here to the, and we're already set in E, right? The 2 levers for M are here. Okay? These 2 levers need to be set in M. We need to be set in 6. You have this H pattern, all right? I used to look at it as the old international symbol. All right? Some of you may not be. I'm dating myself a little bit, but all right? And we look at here, and you got to pay attention to how these numbers are numbered. You got 2 sets of numbers right here on the right-hand side. We have 10, 6, and 2, and we have 11, 7, and 3. Well, 11, 7, and 3 is the farthest column to your right, all right? The 10, 6, and 2 is close to the center where you can move the shift lever up and down, all right? So the 6 is actually in the second column to the left, starting from right to left, all right?
And then the 7 is you move it over more?
And if I wanted the 7, I'd have to shift it over to the complete right-hand side.
All right, so there's little dots there that are kind of telling you that there are different transmission locations. Now, Don, I see, and I don't know if Jason, you can see what Don's doing here. He's turning the, what do you call it, the chuck? The spindle. And why are you doing that, Don?
Because I can't get the gears to mesh.
All right, so there's a little bit of play that you have to be messing with to get these things to mesh properly. And there, I think Don just got it out. All right, later on we're going to give you an example, and when we actually do a part cut as to how to set these all up again, and we're going to review them again. But thanks, Don, for that area. So that's the gearbox. So this whole area over in this section is called what, Don?
This is the headstock and the gearbox. You have a control panel, so it's just the left-hand side of your machine.
Okay. So headstock, gearbox, and control panel. So 3 things over on that side.
Let's review the gearbox that Don just went over. It was a little confusing to me, so let me take it at my pace and maybe this will help you. So let's start. First you have the feed rate chart. Now most of the things on this chart are not going to be relevant to Engineering 153 students. So all the tables starting from the left, the TPI, the D-pitch, the metric, the module, those all have to do with special ways of cutting threads on rods and so forth. So we're not going to use any of that. We're just going to use the 2 tables out to the right. In fact, probably the main one you're going to use is the far right one, which is going to be the longitudinal feed rate chart. So with that longitudinal feed rate, you have several knobs you have to put into the correct positions. All right, the feed mode lever. Don didn't mention this, but I believe, and we're going to get into this later, that this leftmost position is where you're going to be using it. I think that's for the standard feed. The TPI and the MOD, DP, those all have to do with cutting threads, and we're not going to use those. So working around here, when you have to put it in lever M position, there's actually two levers that have to go into the M position, and I've shown those with arrows. The last lever on this lower gearbox is the feed rate lever 1 through 11. Okay, so with the 1 through 11 lever and the M lever, you can get pretty close to what you need. But don't forget, as Don said, there's still the D, E, F, G lever that's up on the headstock that would have to be set. So all the levers needed for feed rate are not shown. There is the D, E, F, G lever that's up there on the headstock. But these are the four levers that you need to work with down here. And remember what Don said, sometimes to get into the gear, you've got to rotate the spindle a little bit to engage the gears.
I know we're going to get to this later, Don, but you know, this thing with numbers on it, what's that?
That's your digital readout. We refer to as a DRO.
Okay, that's the DRO, and that helps us keep track of what?
Our tool position in relationship to our part.
Okay, so we'll get into how that all works in just a bit.
Here's the DRO, or digital readout, that Don quickly went over. It has an X and a Y. So the X is used to track the position of the tool relative to the part as it moves parallel to the axis of the spindle. Excuse me. So this would be known as the longitudinal feed, or the left and right motion of the tool. The lower numbers here are the Y, and that's going to track motion perpendicular to the axis of the spindle. This is you're kind of moving in and in toward or away from you and back towards you. This is known as the cross feed. And we'll get into how to use this device later on. But just remember, we've got X and Y, longitudinal or cross feeds. We're now ready to look at the questions to make sure that you have a general understanding of what went on in this left side lathe video. The first question is, list all the safety procedures that were reviewed in this video. So make a list. Number 2, make a diagram of the control panel and label the controls on it. Number 3, do the same thing and make a diagram of the headstock and label all the controls and the chart that's on there. What does that chart represent? And then 4, do the same for the gearbox, label all the controls and the chart, and mainly the chart that we are going to use in Engineering 153. And finally, describe what type of motion is monitored by the X and Y readouts of the digital readout, or DRO. So what way is the tool moving relative to the part when it's moving in the X direction? And then do the same thing for the Y direction. Remember, hand these questions in to your lab instructor and make them very happy.